So now let's talk about tensional force. Tension is a force that is exerted by a taut rope on whatever holds its end. F is a vector. This implies that tension has also to be a vector, and tension's direction is always along the cord and away from the object. Now this is very important to recognize, and the tensional force is always going to be away from the object that you are looking at. The magnitude of the tension depends on the situation. So if you were to take this idea of these two people holding on to a rope and pulling on the rope, then the tensional force will be equal in magnitude but applied by two different objects, and their directions will be opposite to one another. Similarly, if you were to take mass m and mass m2 and you were to hang them across a pulley, which is considered to be frictionless pulley, then the tensional forces between them will point in the directions shown by the arrow. Both note that tension 1 will equal tension 2 in magnitude, but their directions are going to be away from the masses that you are looking at. Tension. This is the force transmitted through a rope from one end to another. So when we are considering these problems, the assumption is that the ideal cord has zero mass, does not stretch, and the tension is same throughout the cord. If you are to look at it carefully, this assumption may or may not hold in all situations. However, this does hold in situations that we will talk about. If the mass is too big, the rope can almost be called as ideal. So assumptions that you will use in order to solve problems like this will be: string is very, very thin. It is almost approaching an ideal condition. And tension is always along the direction of the string. The string has negligible mass with respect to the crate and the person, because the mass of the crate and the mass of the person are too big. Okay? Force P is what is applied to the crate or on the crate by the person. This work is exerted by the worker on the crate, but it is not directly applied to the crate, but in fact it is applied via the string. This force, again, is going to be called tension. So basically the idea is tension is a pulling force. You cannot push with this force. Now, what happens if you have two masses, m1 and m2, and a person is trying to pull them? Again, note what is going to happen. The person is pulling with the force P. He now has to apply more force. For mass m1 and m2, there are two forces acting on m1. A tensional force due to this person pulling, and a resulting tension 2 force, which is opposite to this one, applied because of the presence of m2. Now on M2, there is only one force, which is the resultant force of T2. Even though that these both will be pulled together and their acceleration will be the same, but the forces that are acting on them are different. For the mass 1, there are two forces acting on it directly, one from the person and one from the mass behind it. For the mass 2, there is only one force that's acting on it, and that is tension 2. Now let's look at this concept question. What do you think the answer to this question will be? What will the scale read in this case? 0 newtons, 10 newtons, 20 newtons, or none of the above? The scale in this case will read 10 newtons. Why? The reason why it will read 10 newtons is because the only force that's acting on it is its weight. For a 1 kilogram mass, if you were to calculate the weight, it is going to be mg, and the mg is actually equal to 10 newtons because the value of g is 9.8. So now let's look at another problem. The scale in this case, now we have two masses across a string across two pulleys hanging down together. The scale in this case will read 0 newtons, 100 newtons, 200 newtons, or none of the above. So take a second to think about it. There are two scales, one attached here and one attached here. What will the scale read? Well, in my opinion, it will read 100 newtons. And this is, note very carefully which mass is actually being applied to it. Only this one, because that's the only one that's going towards pulling on the spring. This one is only hanging. So equivalently, what you could have done is just put like a string through here and attached it to a wall. It would still read 100 newtons. So there is no difference between this concept in this question and this question. Only difference is the fact that one is attached to a roof and the other one is attached to another mass.